In the Milky Way galaxy, there could be thousands of planets resembling Earth, potentially inhabited or suitable for human colonization in the future. Facing challenges like climate change, natural disasters, overpopulation, and epidemics, life on Earth might become increasingly difficult. NASA has set its sights on the TOI 700 system, where a planet known as TOI 700d offers hope as a potential new super-Earth. Why do scientists think TOI 700d might be a good place for people to live? How does NASA exploring the TOI 700 system help us learn about other planets where life could exist? What do we need to figure out before we can go live on planets like TOI 700d? Let's find out. Discovered in 2020 by NASA's Transiting Exoplanet Survey Satellite, or TESS, exoplanet TOI 700d has garnered attention in the search for extraterrestrial life due to its location within the habitable zone of its star, potentially harboring liquid water, an essential factor for life as we understand it. What makes TOI 700d a potentially hospitable environment? Orbiting an M-class star with about 0.412 solar masses and 0.415 solar radii at a distance of 101.4 light-years, the planet is closer to its star compared to Earth's distance from the Sun. Despite this proximity, TOI 700d completes its orbit in just 37.4 days, resulting in a shorter year akin to a month on Earth. However, this difference in orbital duration doesn't necessarily hinder habitability or the possibility of life emerging. While time would progress differently on TOI 700d, it's likely that the planet experiences its own cycles of seasons and vegetation if plant life exists there at all. Now let's talk about the size of this planet. With about 1.7 times the mass of Earth, this EXO world is slightly bigger and heavier. Previous studies suggested its rocky composition might resemble Earth's. While we're unsure about its exact temperature and atmosphere makeup, being in its star's habitable zone suggests surface temperatures could be moderate enough for liquid water. Water exists in various forms across our solar system's rocky planets, mostly as frozen ice at poles. Even Mercury, closest to the Sun, holds some water, though it's too hot for life. Venus's atmosphere is toxic, and Mars has water but mostly locked up. Earth stands out as the only planet with ideal conditions for life as we know it, showing how fortunate the circumstances were for life to emerge. As for TOI 700d, whether it fits the bill as a super-Earth remains speculative for now. However, the numerous water discoveries within our own solar system offer optimism for the presence of water on other planets as well. To confirm TOI 700d's classification definitively, we require more information about its atmosphere composition or magnetic field strength. This calls for further observations and investigations, which the new technical capabilities promise to deliver. TOI 700d was spotted using TESS, NASA's Transiting Exoplanet Survey Satellite, launched on April 18, 2018. Aboard a Falcon 9 rocket by SpaceX, Elon Musk's space company. Initially slated for a 2-year mission from 2018 to 2020 to hunt for exoplanets, TESS has surpassed expectations, prompting 2 mission extensions. Its sensors focus on the sky near the ecliptic, facilitating the detection of exoplanet transits. So far, TESS has identified 50 small and Earth-like exoplanets, with scientists worldwide utilizing its data to study exoplanet properties, atmospheres, and planetary formation beyond our solar system. The observation satellite known as TESS follows a highly elliptical orbit around Earth, referred to by NASA as a P2 orbit. This orbit allows TESS to complete one orbit around Earth every 27.4 days, scanning a different part of the sky each time. Positioned between 108,000 kilometers and 373,000 kilometers from Earth, TESS's orbit is much farther out compared to communication and weather satellites, which typically orbit around 36,000 kilometers from the Earth's surface. TESS's elliptical orbit enables it to survey almost the entire sky without being hindered by the sun's brightness. This capability allows TESS to search for exoplanets orbiting dim stars, using the transit method to detect planets as they pass in front of their stars, causing small dips in brightness. The brighter the star and the larger the planet, the easier it is to detect them from Earth. This is particularly beneficial for discovering small planets orbiting faint stars, which were harder to detect with previous telescopes. Overall, the TESS mission has been a significant success, not only because of the discovery of the potentially habitable TOI 700d planet. TESS also identified 4 other exoplanets within the TOI 700 system: TOI 700b, TOI 700c, and TOI 700e. While TOI 700b and TOI 700c are not within the habitable zone, TOI 700e, which is about 10% smaller than its neighbor TOI 700d, could potentially have liquid water and a temperate climate, making it another promising discovery. Launched in 2022, the James Webb Space Telescope is poised to revolutionize the study of exoplanets, particularly in detecting water in their atmospheres. A primary objective of the mission is to analyze exoplanet atmosphere for biomarkers, with water being the most crucial one. Additionally, the telescope can identify conditions that may not support water or life, such as toxic gases or other chemical compositions. Using a technique that involves analyzing light reflected from exoplanets as they pass in front of their stars, James Webb can reveal unique light signatures, or light auras, for each planet. This allows for the detection of changes in light caused by the atmosphere and surroundings of the exoplanet. Water molecules, along with other gases or elements, produce distinct wavelengths, enabling the telescope to accurately determine atmospheric composition by examining the entire spectrum of light passing through. However, predicting when the telescope will observe specific exoplanets, such as TOI 700d, remains challenging at the moment. Since the telescope is an international project with hundreds of scientists worldwide sharing observing time, it might be a while before TOI 700d gets its turn. Another telescope, the extremely large telescope of the European Southern Observatory, set to launch in the Chilean Atacama Desert next year, might be quicker. This advanced telescope can also analyze exoplanet atmospheres. If TOI 700d turns out to have a water-rich exoplanet with an Earth-like atmosphere, it would be incredibly exciting. But what practical steps could we take to reach this world? Contacting exoplanets involves significant challenges. Despite being relatively close at just over 100 light-years away, TOI 700d is still immensely distant considering our technological limits. Since radio signals can't travel faster than light, communication would take over 100 years, assuming any inhabitants receive and respond to our messages. And if they do, their reply would take another century to reach us, unless they possess advanced methods for faster communication. Flying to TOI 700 with spaceships would be a dream, especially if it turns out to be a second Earth or inhabited by friendly aliens. However, it's hard to predict when this might become feasible. Even reaching the nearest star, Proxima Centauri, which is just 4 light-years away, is beyond current technology and propulsion systems. Do you believe humanity should rush to find a new home in space? Or is the fear for Earth's future overblown? Share your thoughts in the comments.